I'm going to give you a couple of, one exercise first. Fractions. Let's write it down over here. Fractions. Then we will start with addition. I think addition is the easiest one of them all. Well, not really the easiest one. It's pretty easy once you get the hang of it. So addition. And let's say that we have 6 over 7 plus 2 over 3. What would happen if I covered oh, this sucks. Well, that kind of works. What if I covered the denominators and just looked at the numerators? You just add them, right? What I'm trying to say with this is that if I give you variables and I give you an equation like the one that I gave you Friday, and it has all those fractions, all you had to do was cover the denominators, and it helps you see a little better what you need to do. Because in reality, believe it or not, what throws you off is not the go away. There it goes. What throws you off is not the actual problem, but the fractions. For whatever reason, it gives the whole thing a different meaning. So I know a lot of you learn how to do this a different way, but I'm going to show you a very easy and fast way that works with both addition and subtraction. Here's the following. It has 3 very easy steps. The first one is to multiply the denominators. You can write those down. Those are your notes. Do not waste too much time making it too colorful and too pretty. That's not the idea of it. Sometimes when I'm at school, I get too caught up trying to make sure that my notes are looking good and they're all in order. And by the time I'm done with the class, I have no idea what the professor talked about because I was too busy writing stuff down. So listen, interpret. Multiply denominators. By that, I mean this. You multiply that times that, what does it give me? 21. So when you multiply that, I get 21. And I'll color code it just to give you an idea. The second step would be to multiply the numerator by the denominator. You're like, huh? The numerator of the first fraction by the denominator of the second fraction. 6 times 3, what is it? 18, and that goes on top. Do not forget to transfer the sign. And now we're going to do the third step, which is to multiply the denominator by the numerator. The denominator is 7, right? 7 times 2. And that gives me what? 14. Now, all I have to do is worry about what's on the top. And I'm going to put this in a different color and highlight it, because what really matters is this area right here. Whether you're adding or subtracting, that's where the fun happens, in that little top part. Aquí. That means here. Doing the most. All right, so anyway, now what do you do there? You just add, right? So 18 plus 14, what does it give me? Huh? 32 over 21. What kind of fraction is that? Improper. Una fracción impropia. I don't know. No. Oh, yeah. It is not an inappropriate fraction. It's just an improper fraction.
That's inappropriate.
She said it. It's improper fraction. That's different. It's not proper. So when it's an improper fraction, what do you do with it to turn it into a mixed number? How many times can the denominator, the number at the bottom, can go into the numerator, the number on top? And I believe it's 1 time. And what do you have left? 11. 11 over 21. And you're like, how do you get the remainder? Here, how do you do it? You get 21 outside, and you divide 32. It's inside, right? It goes in there one time, so 21, and you get 11. So this is this guy right here, and this is your remainder. Yes, the denominator stays the same. The number on top, whatever you get, the quotient, that's going to be your whole number. And your remainder, this is the one of the few times we actually want to know what the remainder is. Because that's going to be whatever is left. Are we following? Good. Right here. All right. I'm going to ask you to do the same thing with subtraction. The only thing you have to worry about is what we do in the yellow area where it says aquí. What are you going to do there? That's the only thing that matters. Everything else stays the same. The only difference is what you do in that little circle. Well, if we're subtracting, what do you do? Okay.
It's like if you were going to subtract, you do the same except subtract.
So for subtraction, yeah. All right, so you do 6 over 7 minus 2 over 3. All right, go ahead and do it. On your, oh, I know what I'm saying. All right, so the homework for the addition will be the following, very quickly. Let's see, we have 11 over 14. This is the homework number 1. I'm going to put it randomly. Plus 8 over 10. There's the homework. Don't write it down. You can need it later. I want you to do it later. Anyway. Yes, a lot. Yeah, we're not even close to it. Don't write the homework down until the end. Don't worry about it. You can go back to the video and watch it. Or you can do it now. I don't care. But first step is to multiply the denominators, right? So I get 21 again, right? And technically, I'm supposed to get the same thing for the other ones, right? Multiply the numerator times the denominator. I get, what did I do different here? Oh, it's this way, right? Sorry, JK. Hang on. What am I doing? All right, so the numerator times denominator. What am I saying? So we get 18, right? Then you subtract, and you multiply the denominator times the numerator. What am I doing? Okay, that, and you get 14, right? And this should be easy. What is your answer? 4 over 21. Can you simplify that? There you go. That's all you get. It does not. If you heard that, she's incorrect. You cannot divide 21 by 23 and get 21. That's not right. Anyway, so that's all for subtraction. Here is one that you can do for homework for subtraction that you will do. Homework 2, it's going to be, make it easy, 23 over 24 minus 8 over 9. All right. We're going to move on to multiplication. Multiplication is by far the easiest operation with fractions. It doesn't require much. It's basically common sense. You just do one thing only. What? Can somebody tell me what? Yes, but how? Multiply across, not cross multiply. That's different. That's butterfly. I'll give you a different answer. Cross multiply, across, like that. So I'm going to write it down. I'm going to use the same numbers. 6 over 7 times 2 over 3. And there's only one step for that. It says multiply across. Look at my little arrow. It just tells me that I have to go right across. So you multiply the top numbers, 12, and the bottom numbers, which is what? Can I reduce that or simplify that? I cannot. So my final answer is 12 over divided by or out of 21. That is the easiest thing ever. The what? Oh, I can? Yeah, that's right. What is 12 divided by 3? I stand corrected. There we go. You can't simplify. I don't know why I didn't think it would. I didn't think of 3. JK. All right. So that's going to be your example. That is the easiest thing you can do. Multiplication. Your homework for that is going to be homework 3. It's going to, let's make it easier too. 12 over 15 times 6 over 8. That should be easy. This is just practice problems. What? I don't know what you said, but sure. No, because you won't learn much. All right. Division. Divisions are also very easy. And I'll tell you why. Because we don't divide. We turn them into multiplication so we can make it easier. That's why. KCF. So we're going to use the same number, 6 over 7 divided by 2 over 3. And last week, I mentioned something called keep, change, flip. So I keep the first fraction the same. I change that sign to multiplication because I want to make it easier. I don't want to divide. And then I flip the next fraction. So it'll be 3 over 2. And now what do I have? Yeah, well, yeah, I have a multiplication. I just multiply it right across. And I get 18 over there. I get 14 over here. I can simplify or turn it into a mixed number because it's an improper fraction, right? 14 goes in there one time, and we have 4 out of 14 left, right? We can simplify this guy over here to 1, and we get, is it 2 out of 7? 2 out of 7, and that is my final and simplest form for my answer. When we say simplest form, that means the smallest you can go when you're simplifying. Yeah, because you have an improper fraction. Improper right here. When you have an improper fraction, always go all the way down to a mixed number. Yes, you said, wait, what happened? The whole thing? Which part here? Here? Okay, well, the beginning. So this is what you got, right? 6 over 7 divided by 2 over 3. We don't want to divide because division's crazy, sounds complicated. So we just turned it into a multiplication problem because we know that's easy, right? We have a rule or a little tool that we can use called KCF, keep, change, flip. Are you following? So we're going to keep the first fraction. We're going to change that division into a multiplication, and we will flip the sign. And now we have a multiplication problem that is very easy to do, right? Are you back on track now? Are you sure? We only change it when we're dividing. That's it.
So you keep the first one, then you keep
No, you change
the division sign, and then you flip.
the last. Just follow that. Keep, change, flip. Here's another, yes. Here's another method that we use for division. Some kids prefer this one than the other. It doesn't matter which one we use. But I call it outside over inside. It's like a little monito. But this is what it means. The first fraction divided by the second fraction. Follow. Do not lose me. A little doll. 6/7. Hang on. Yeah. Divided by 2/3. It's not. Outside over inside, my other kids call it the rainbow method. Multiply these two and you get 18. And then multiply the inside and you get 14, which is the same thing as you got over here. And then you just simplify it and you get 1 and 2/7, right? It's the same thing. It's the outside over the inside. Are you following? I mean, I think it's pretty easy. Outside over inside. Multiply the outside numbers, 6 and 3. Multiply the inside numbers, 7 and 2. Yeah, every division problem that has a fraction in where you have a numerator and denominator. If you have a mixed number somewhere in there, turn it into an improper fraction, you can do that. Does that make sense? Yes. These two are only for division, the KCF and the outside over inside. Yes. Yes, look over here. Outside over inside. That's what I call it, outside over inside. When you multiply the outside, whatever you get, the product will be on top. And whatever you get from the inside, that product will be at the bottom. It doesn't matter which one you use, as long as you know you got it and you're confident with it. They both work. Yes. Now, you're going to lose the part of it. No. All right, so here's the division problem that I'm going to give you. Let's do, yes. Homework number 4. It's going to be 8/12 divided by, let's make it easy. All right, there it goes. That will be the answer. I mean, that will be the problem for number 4. Now, these are easy, right? Like, now that you know how to do them, be like, oh, I got this. The problem is remembering them. So you have to practice on them a lot. I highly suggest you go to IXL and do some of those on your own. So no, we're not even close to being done. Yeah, that's plenty of time. All right, so what happens if I'm subtracting, hang on, what if I have, for subtracting, 3/4 minus 8/9. Try that. All right, so let's work it out. That'll give me 36, right? This is what? Now, if you're confused, you're like, why is it negative? Well, separate it, and now you have 27 girls and 32 boys. You end up with a lot of boys left, right? So that's your answer. Yes. Of course. Yeah. All right, so, hey. This is 5. And I'm going to give you 5/7. Yes. No, not 5/7. Huh? I don't know. I just came up with these numbers. Very easy. 4/7 minus 6/8. What does it give you? All right, the next one. Yeah. The next one is going to be, what if we had negatives on both sides? Like -3/4 minus. All right, go. Okay. All right, so let's work it out. Everything is the same, but here's a little clue. If you have a negative number on the outside, keep the negative on the numerator, just for now, because it helps. So when you multiply these two, what do you get? And then -3 times 5, -15, right? I said -3 times 5. And if it tells you if the signs are different when you multiply, you get a negative answer. So then right here, these are both the same, so that'll be what? 8. Move the sign over. And now you look at it. A bunch of boys, right? How many? Thank you. Guys, look. Hey, shh. Do we have any girls on top? They're all boys. 15 boys, 8 boys. I feel like I keep saying this almost every day, and it's still not drilling to your heads. Use the boy, girl situation. Minus sign. Well, then don't use it, but I see that the other one doesn't work either. So, it's the same thing. Guys, the negative and the minus sign are the same thing. Yes.
How would you do it if you convert it to a mixed number?
It'll be, the whole thing is one number. It'll be -1, and whatever you have left, 3/20.
Not negative.
It's still negative because, guys, let me show you that same fraction in different ways. Pay close attention and please don't lose me. -23/20 is the same thing as 23 over -20. Is the same thing as -23/20. And it's the same thing as -1 and 3/20. It doesn't matter where you put the negative sign, the whole thing is negative. Do we understand that? But for the purpose of this, I want you to put the negatives on top so that you know you multiply in a negative times a positive when you multiply diagonally. Yes.
So can you put the negative sign before the 3?
Where?
Mixed number.
Like here? Well, that would be no. I wouldn't put it there because you're saying it's a +1 and a -3, and that means you will have to subtract those. So no. Whenever you have a mixed number, just put it right before the number. That's it. If you're lost, please go back to the video. But here is your homework on that part. Yes, you're going to get one over there. I know you got it.
No, don't say that. Then you can give them homework.
La, 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 la.
That's not how we sound.
That's exactly how y'all sound.
That's not. Mr. Christian Michael.
All right. Here's the next one, guys. This is the one that you had on your test, and y'all look like it was something crazy or out of, I don't know. But I'm going to use easy numbers. 1/2 plus 2/3 minus 1/4. It was similar to that. You were like, I don't know what to do. I just put X's next to it, but it's the same thing. Work it out. Go. Work it out. Yes. Hang on. Sorry, guys. Like the time is like ticking, so I need to make sure I get to it. Easy. This is what you can do. I advise you to get the ones that are the same signs. This is positive, and this is positive. This is negative. So I'm going to box this guy right here, and I'm not going to use it. I'm going to take care of the first two, and that makes it all easier. So I'm going to get 2 times 3 is 6. 1 times 3 is 3. Move over the sign. And then 2 times 2 is 4. That gives me 7 over 6, right? Now that I'm done with that part, I'm going to unbox this guy and bring it over here. And that'll be negative 1/4, right? Now I can work that one out. 24, 28, minus 6, 22 over 24. And I can simplify that to what? What? 11 over 12. That's my final answer. By the way, that's all you had to do. You did something wrong. Go back to it and see what went wrong, what calculations went wrong. Hey. Gracias. So, what you want you to do is to understand that you have to separate some of those to make it easier for you, because you can't just do all of them at once. You go piece by piece, just like Pem does. When you have all these operations and you go in order, the same here. Just go from left to right or add the ones. Addition and subtraction, you can move them around, and it's still going to give you the same thing.
Is there going to be a less problem?
No. So here's your problem. That's going to be, let's give 4 over 5 plus 2 over 8 minus 3 over 6. Good job. You can do that from the beginning. That was another thing, guys. You can simplify from the beginning to make it easier for you to get calculations. Remember, the bigger the numbers, the bigger the calculations. See, if you can simplify from the very beginning, and you can simplify 2 things in here, you can probably make it faster and easier. So tomorrow, tomorrow, I know everyone is going to bring me their own homework.